Hello YouTube, RJ. Well, got another box on the bench. Got to stop getting on eBay. Gets me every time. Got a new test instrument for the lab. Let's open it up and see what we got this time. All right, let's see what we got. Oh, it's garbage. And what do we have here? We have what looks like kind of a beat up box, which is exactly what they told me. Simpson 260 voltmeter. And I was told it's in the original box, and the box was in pretty rough shape, but I was told the instrument is in excellent shape. Supposedly even has the original probes with it. So let's see. There's the top face. We can tell that. They weren't joking about the box being in rough shape, but you know, it's nice to have the original box, even if it's not in great shape. So let's see what we got here. Ooh, look at that. It's even shiny. Something I don't have. It's got a bunch of probes. Don't know these are original. Maybe he didn't say original. Maybe the listing said it had probes with it, and it does. It has a nice pointer probes. Got a bunch of nice and clamps and everything. That's nice. Of course, the guy that sold it probably got it at State's Fair. He doesn't know what the original probes look like, so he might not know. Okay, protect window surface from scratching and avoid exposure to sunlight. It's got the actual label that came on it from Simpson. Oh, this is really nice looking. I hope it works near as nice as it looks. Handle's not floppy. It's got drag. That's so nice. Big thing is, let's see what it looks like in the battery compartment. That's always the scary one. So let's grab a screwdriver and take a peek. That's going to tell a lot. It's actually got an old battery in it. I don't know if it's old. It's an industrial alkaline maximum. No leakage. Everything is spotless. Look at that. I'll definitely be putting a new battery in before we do. What's the 9-volt look like? Industrial Energizer. Well, we'll industrial replace that with a brand new battery so that we're on good footing. But man, spotless. This thing is spotless. Let me get a couple batteries. I'll be right back, and we'll pop a couple batteries in this thing, and we'll see how it works. Okay, I'm back with a set of batteries. So let's go ahead and get the D cell in here. Okay, and the 9-volt. So number one, I know I got good batteries. They're got a good charge, and the other, they're a long ways from leaking for me. So get this thing closed up, and we are ready to do some testing. So let's put her down. Let's get some probes set up. Okay. Common. AC/DC up to 1,000 volts. That's DC positive is on there. Let's go ahead and do this. I'm going to go ahead and center the needle. I'm going to stick my head in now, so hold on a minute. I'm going to get it dead on. Right there. Okay. Was pretty close, but now it's dead on. So I think what I'm going to do is, if you don't mind, I'm going to move you down much closer where you can really see the meter close. And then I'm going to try to get you focused in good. Okay. Now, why don't we start out on the 100 volt scale. And I'll grab some probes from the linear power supply.
Hold up. Wait a minute. Something ain't right.
Okay, this is future RJ, realizing that I kind of messed up. I'm jumping into testing all these higher voltages from the power supply and stuff, and I haven't done my very basic test, the one we do on all our meters. We always use our reference. So let's let's pull the reference out and let's find out how this thing looks, starting right off the bat. And then we'll jump back to the previously scheduled program, see how everything looks there. But first, so let's start out with our 5 volt, get everything nice and secure, and let's put this plus DC on the 10 volt scale. Let's see what it says we get with the reference. It says we get exactly 5 volts. Exactly. So that's great. Okay, well, hey, how about the 5 milliamps? How's it going to do on that? Let's go to 5 milliamps. And where do I need to be? Looks like I need to be on the positive 5 amp maybe. I'm going to say I need to be here. I said I've not used a Simpson before, so cut me some slack. So let's see what happens. Well, that didn't work. So common. So not the 5 amp. There, I guess you stay here unless you're on one of these scales where it reads. So I'm on the 5 milliamp scale. So it'd be the 50 scale. And it's not quite reading 5 milliamps. 4.6 milliamps. So I'm not reading exactly accurate there. Now, it's possible I'm doing something wrong on it, but likely what it is this thing probably puts enough load that my little reference, because it's designed around having no load from a digital multimeter. So this thing's probably put enough load. That's probably normal. I actually believe that's probably normal. This thing has so little output, you can't, any load is going to pull it down. So I would say that's probably fairly representative of what you'd expect to see from it. Now, of course, resistance is another thing, and it should be accurate on resistance. So voltage and resistance shouldn't play a part. They should be fine, which so far the voltage looks great. Let's go ahead and take a look at the resistance. So if I hook this up and go to R times 1K, actually, let's go R times 100, 1K. Okay, on R1K, I read just the meter just barely. I'm not sure how well you're seeing that, but it's just barely over 5. So, you know, though, it would help if I calibrated it. I'm going to have to get used to working with this meter. So, that's 0 ohms. I know all of you that use Simpsons all the time are screaming that, you know, I'm forgetting to do this and that. Cut me a little slack. Never worked with a Simpson meter before, so it's going to take a little practice to getting used to all the little. I'm used to working with digital multimeters where you don't have to think any, and you have to think a little bit with these. Okay, now I'm reading just shy of 5 ohms. So let's check our calibration one more time. We're real close. We're probably 4.95 or 6, I would say. I mean, you're really close. So it's not far out. Now that was absolutely 0. So it's calibrated. Let's see what we read now. Ooh, that thing is so close to being dead center of the 5. It's probably reading 4.99 ohms. It's, considering the precision of this device, I think it's pretty well dead on. I think we're looking at everything good. Like I said, on the milliamps, I'm assuming that's a little bit of load. You have no current per se on this thing. It can't supply much current. So being that it's a digital multimeter tester, not a 20,000 ohm per volt meter tester, it's really designed for that. I'm going to say we got a winner here. I think that's very, very good for this type of meter. So I'm very happy. So now we'll get back to our regularly scheduled program. I actually think I'll use my other power supply. Give me just a second, because being digital, I'll be able to tell much better exactly where. This power supply is actually pretty accurate. Darn accurate. Accurate enough for me. Probably more accurate than this meter, actually. So let me get it on, and we'll use it to do the testing of the voltage. I'm going to set the volts at 1 volt, and with that, we should be ready. I'm going to turn it on. We'll see if it reads a volt. Helps if you put it in the right place. This side pointing at 1. Now, still looking good for 0, so kick it on this time. I'm not reading anything. Oh, I see. I'm in the wrong place. Never had one of these meters, so hang in there with me, because obviously, try this again. This is the first time using one of these meters, so you have to bear with me a little bit. I'm 1 volt DC. There's my DC scales. Where's my 1? The 10 is going to be my 1. So I would say this thing is pretty accurate, actually. Let's turn that off. Let's get the 2.5 volt scale. Again, we'll short the probes together and make sure we're reading 0. We are. Okay, I'm on 2.5. I'm going to turn 1 volt on. Let's see, I'm on the 2.5, so 250, about dead on 1 volt in my opinion. So let me change the voltage some. Let's turn the power supply off. Let's go to 100 volt. I can't do 100, I can do 60. There's 25. Looks good. See, here is 30. So we're on the 100 volt. It's reading maybe a tad high on that. Let's go to 40 volts. There's 40 volts. It's reading fairly close on that. You probably have some parallax. I don't know how accurate it looks to you, but there's 50 volts. It's reading just a little high. Of course, I need to put my meter on this. There's 60 volts there. So we could hook up our other meter and verify our power supply, but I think power supply is pretty accurate. So I'm going to say this thing's reading pretty accurate, as high as I can go DC volts. So very, very happy. I'll check it out on AC and ohm meter, but at this point, I think it's prime. I mean, this thing looks like brand new. Like I said, it's still got this caution sticker from the manufacturer about putting it in the sun and cleaning it with water and stuff like that. Looks fantastic, other than wiping with a little bit of damp cloth to get some of the dust off of it. I mean, this thing is immaculate. I couldn't be happier. I'll check out the AC. I'll check out the ohm scale, but I think it's going to be perfect. This thing is, I've got to learn to use it. Obviously, all these, not having used a Simpson before, but I'm very, very happy. I think I got a great meter. We're not going to have to renovate this thing or do anything with it. That's going to be a nice little tool to have on the bench. I've got a really nice Simpson 260 series 6X LPM. So this is the one that everybody wants, because it has the regular banana jack, so all your probes can work on it. Doesn't have the reverse or the weird jacks. The other thing is, it has the protection built in. This is basically the loaded up one. I looked at this. You can buy this meter brand new from Simpson through their authorized dealership. They're about $800, but you can buy one brand new. And I would say that if I bought a brand new one, it wouldn't look any better than this thing. Thanks. Appreciate you tuning in. Got another nice piece of equipment for our bench. See you in the next video.